Right now, you're probably sitting still. Maybe on your couch, at your desk, whatever. But what if I told you that still is the fastest you have ever moved in your entire life? It sounds like a riddle, but it's the simple truth. Right now, you are on a cosmic joyride, hurtling through space at speeds that are almost impossible to imagine. We're not talking about a gentle float. We're talking speeds that make a fighter jet look like it's standing still. In the next few minutes, we're going to unpack this mind-bending reality, layer by layer, to show you just how fast you're really going. And fair warning, the numbers are about to get wild. The grand illusion of stillness. Before we get to the huge numbers, let's tackle the obvious question. If we're moving so fast, why don't we feel it? Why isn't your hair a mess and your coffee sloshing all over the place? The answer is a simple concept: constant velocity. You only feel motion when you accelerate, when you speed up, slow down, or change direction. Think about being on an airplane. You feel the raw power during takeoff as you're pushed into your seat. You feel the turns. But once the plane hits cruising speed, that sensation vanishes. If you ignore the engine hum and close your eyes, you could almost believe you're perfectly stationary. A flight attendant can pour a drink without spilling a drop, because everything in the cabin is moving together at the same speed. Earth is that airplane, just on a cosmic scale. Everything, you, the building you're in, the air you breathe, is moving in perfect unison. We are all passengers on this giant, spherical spaceship. Because there's no relative motion for our senses to pick up on, we feel nothing. Gravity also does its part, holding us firmly to the ground so we aren't just flung off into space. This feeling of stillness is a powerful illusion. For thousands of years, people looked up, saw the sun and stars moving across the sky, and came to the logical conclusion: Earth must be the stationary center of it all. But we now know the truth is far more exciting. Let's start with the motion happening right under your feet. Layer 1, the planetary spin. The first layer of motion is Earth's own rotation. Our planet completes a full spin on its axis not in a neat 24 hours, but in 23 hours, 56 minutes, and 4 seconds. That's called a sidereal day. The 24-hour day we use is a solar day, which is how long it takes the sun to get back to the same spot in the sky. So, how fast is this spin? Well, it depends on where you are. At the equator, the widest part of the planet, you're traveling along a circumference of about 40,070 kilometers every day. That translates to a blistering speed of about 1,670 kilometers per hour, or roughly 1,037 miles per hour. To put that in perspective, you're moving faster than the speed of sound, without making a peep. But that speed changes with latitude. As you move towards the poles, the circle you travel gets smaller, so your speed decreases. If you live in a city like New York, at a latitude of about 40 degrees, you're still cruising at a cool 795 miles per hour. At 45 degrees latitude, the speed is about 1,180 kilometers per hour. And if you were to stand right at the North or South Pole, your linear speed would be basically zero, you'd just be rotating in one spot. Space agencies cleverly use this. By launching rockets from sites at lower latitudes, like the Kennedy Space Center in Florida, they get a free speed boost from Earth's rotation, which helps save a lot of fuel. It's like having a natural, built-in launch assistant. But this is just the first step on our journey. Layer 2, the solar orbit. As fast as the Earth's spin feels, it's nothing compared to our next layer of motion. While our planet is spinning, it's also hurtling through space on its orbit around the sun. This isn't a lazy circle, it's a high-speed race we've been running for 4.5 billion years. To complete one orbit, Earth travels about 940 million kilometers, or 584 million miles. To cover that insane distance in just over 365 days, our planet screams along at an average speed of about 107,000 kilometers per hour, or 67,000 miles per hour. That's nearly 30 kilometers every second. At that speed, you travel a distance equal to the Earth's own diameter in under 7 minutes. This speed isn't perfectly constant, either. Our orbit is a slight ellipse, so Earth moves a bit faster when it's closer to the Sun in January and a bit slower when it's farther away in July, but the changes are so gradual we never notice them. And we're not even the fastest. Mercury, the closest planet to the Sun, zips around at a mind-boggling 170,000 kilometers per hour, while distant Neptune plods along at a relatively leisurely 19,500 kilometers per hour. So, on top of spinning at over 1,000 miles an hour, you're also orbiting the Sun at 67,000 miles per hour. But we're just getting warmed up. Layer 3, the galactic voyage. Our sun isn't just sitting still in space. Our entire solar system, the sun, Earth, and all the planets, is on an even grander journey. We are all part of a colossal structure called the Milky Way galaxy, and we're orbiting its center. Our solar system is located about 27,000 light-years from the galactic center. From here, we are being swept along in a gigantic orbit, orbiting the combined mass of the galactic center at an average speed of about 828,000 kilometers per hour, or roughly 515,000 miles per hour. Even at this incredible speed, it takes our solar system about 230 million years to complete a single lap around the galaxy. This massive chunk of time is called a cosmic year. Think of it this way, the last time our solar system was in this exact spot, dinosaurs were just starting to roam the Earth. We've only completed this orbit about 20 times since our solar system was born. Every 90 seconds, you travel about 20,000 kilometers on this galactic path. We're all caught in a majestic, swirling river of stars, gas, and dust. Layer 4, the cosmic drift. So, we're spinning, orbiting the sun, and hurtling around the galaxy. That has to be it, right? Nope. The entire Milky Way galaxy itself is moving through the universe, being pulled by the gravity of other, even bigger structures. So how do we measure the speed of everything? What's the ultimate reference point? Scientists found one, the cosmic microwave background, or CMB. The CMB is the faint, ancient radiation left over from the Big Bang that fills the entire universe. By measuring our motion relative to this fossil light, we can find our true speed through the cosmos. Data shows the light is slightly blue-shifted, warmer, in the direction we're moving, and red-shifted, cooler, in the opposite direction. Based on this, our solar system is moving at about 370 kilometers per second, which translates to a mind-shattering 1.3 million kilometers per hour, relative to the CMB. But that's not the whole picture. Our Milky Way is part of a local cluster of galaxies called the Local Group. This whole group is being pulled toward massive gravitational points. In the past, this was called the Great Attractor, but we now see it as the gravitational center of our home supercluster of 100,000 galaxies, known as Laniakea. As a result of all these cosmic tugs of war, our entire galactic neighborhood is moving at about 620 kilometers per second, or a staggering 2.2 million kilometers per hour, 1.4 million mile per hour relative to the CMB. It's incredible to think about the layers of motion we're all a part of, from our planet's spin to our galaxy's wild ride through the cosmos. If this journey through space and time blew your mind, consider subscribing for more cosmic questions like this one. And if you're curious about just how big everything is, check out our video on the true scale of the universe. So let's bring it all back to you, sitting there and feeling perfectly still. You are on a planet spinning at over 1,600 kilometers per hour. That planet is orbiting a star at 107,000 kilometers per hour. That star is hurtling around the center of a galaxy at over 800,000 kilometers per hour. And that entire galaxy is streaking through the universe at a jaw-dropping 2.2 million kilometers per hour. These motions don't just add up since they all point in different directions, weaving a complex spiral path through space-time. But they are all happening, all at once, to you, right now. That feeling of stillness is just a trick of perception, a result of moving in perfect harmony with everything around you. The reality is you're anything but still. You are a cosmic traveler on a journey of unimaginable speed and scale. At this very moment, you are moving faster than you have ever moved before,